Hey, how's it going? As you're preparing for your U substitution quiz, I was looking at the WebAssign review and wanted to give you some helpful hints and show you some ways to solve a couple of these questions. And the first one I wanted to look at with you was number 6. So your problem should have the same exact function here, this derivative to start out with, but your point isn't necessarily going to be the same as mine. Mine has the x coordinate 2 and the y coordinate 3. Yours might have another, but that's the part at the end of the problem where our answers are going to differ. But the setup of this is really good review, so that's what I wanted to try. So on number 6, it says you're given a derivative and you want to find an equation for the function f. That means you got to integrate. You know you have to integrate in every single one of these, but if we want f of x, we have to integrate the derivative in terms of x that's given. So here's the u sub practice taken with respect to x. So that's step 1. We want to integrate this, and let's use some u substitution. So we're picking u. When we see a square root or parentheses with a power on the outside, it's usually a smart idea to pick the inside for your expression for u. So we could let u equal 8 minus x squared. And du dx happens to equal negative 2x, which is great news because we have a negative 2x in the problem, and du equals negative 2x dx. And du over negative 2x equals dx. Okay, so there's your initial setup, and now we go do a plug-in. So we'll take both of those things back to the original integral. It's the integral of negative 2x square root of u, and then instead of dx, we write du over negative 2x. Remember I said that negative 2x was great news? Here's why. This whole negative 2x cancels with that whole negative 2x. And what we have left over is not a big deal to integrate. We want to integrate u to the 1/2, which is the square root of u with respect to u. So I think now's the time. Integrate, we go up a power, so u to the 3/2, as long as we divide by 3/2, so multiply by 2/3, and it's indefinite, so we'll put a plus c. And this is your f of x, but if we really want it to be in terms of x, we have to sub back in for u. So 2/3 of, what do we call u? 8 minus x squared to the 3/2 plus c. And we are almost done, but we do have this initial condition given. My point was 2, 3. If you plug in 2 for x and 3 for y, you should get a good answer for this. So I'm running out of room here. I'll say 3 is the y, so 3 equals, let's go black, 3, oh, let me write up there. So we'll say 3 equals 2/3 of, give myself a little more room here, 3 equals 2/3 of 8 minus 2 squared to the 3/2 plus c. Just carefully in your calculator, plug this in. When this whole thing gets typed in, I would just make sure it's an exact value and then subtract it from the 3. Then your final answer is f of x with that c plugged in. So that should help you get c to have a final function. 7, you could argue there's 2 of these on this WebAssign that are very tricky, and 7 is one of them. 7's out of the ordinary tricky because it looks so tame to start out with, but you need, spoiler alert, a little bit of back substitution. I'll show you what I mean. When you originally look at this integral to take, does your mind think, oh, just like in the last problem, I'm going to pick the inside to be u. So I'm going to let u equal the inside of that radical, x plus 6. And it seems like everything's going fine because du dx just equals 1 and du happens to equal dx until we hit this roadblock. If I go back to the original function, you have this pesky x that's hard to get rid of. It's x squared of u, and in for dx we can plug in du, but this is problematic. In all the other problems, this was the step where the x expressions happen to cancel, so we have to make something happen here. This is like one of the ones from my review sheet at the very, very end, and you'll see another video of me solving that. And we've solved it in the previous days too. We saw it, I think, on U sub day 6 or 7. We call it back substitution. Would you agree with me that if we said u was equal to x plus 6, we could use this fact however is convenient for us? And how it would be convenient would be to get x in terms of u. So that means x equals u minus 6. And that's what we're going to use here. We want this whole thing to be in terms of u instead of x, and this is the way to do it. Integral of u minus 6. Instead of writing square root of u, I'll write u to the 1/2. just so it'll be easier to integrate in another step, and then a du afterwards. So that's a huge move, back substitution, and now it's something that's all in terms of u. And even before integrating, do yourself a few more favors. Let's get it in a format that's easier to take an antiderivative, make it, add the powers, right, when you distribute to both parts of those parentheses. So u to the 1 plus a half, 3 halves, minus 6 u to the 1 half. And then du outside of it. And both of these parts we can integrate, right? We just have to do one at a time. This is take it up a power, u to the 5 halves. As long as we divide by 5 halves, we'll put a 2/5 there. Minus 6, we're bringing this up to the 3 halves, u to the 3 halves. And then dividing by 3 halves, we get 2/3, like that, plus c. And we want to simplify a little bit and plug back in. We'll actually take this one the full way. So answer is going to be 2/5. 2/5. Instead of writing u, we can write, what do we call u? X plus 6 to the 5 halves. That's the first part of your answer. Minus, in my problem, you might not have had a 6 there. So minus 2/3 of 6. So minus 4. And then x plus 6 to the 3 halves. And don't forget plus a capital C at the end. That should look pretty good. Okay. There are 2 more I wanted to look at the very least. The next one was 11, if you could skip down to there, just because it had a bunch of trig in it. And mine has secant and secant and tangent on the inside, and my constant value is a 3, whereas yours might be a 6 or a 7 or whatever it may be. We'll adjust the problem accordingly. Also, beware of these problems where we're using a t variable instead of x. It's going to be like that in number 11. It's going to be like that in number 12. I say step 1 before, and that's another reason to take a closer look at this one, before jumping right into u substitution, distribute into the parentheses. We might see a couple expressions that if we look back to our list of trig antiderivatives, we'll recognize. So this is the integral of secant times secant, secant squared of 3t, plus now secant times tangent, secant of 3t, tangent of 3t. All taken with respect to the variable t, like that. And I have 3's in my problem. This is from our list of trig antiderivatives, as is this. The antiderivative of secant squared, if I look at the list, is going to be tangent. Antiderivative of secant tangent is going to be secant. The only problem we have is this 3t, and one way to think about it is you could sub in the letter u for the innermost part of that function. So I could say let u equal 3t. Gives me a pretty simple derivative, du dt equals 3. Notice, I did this quickly, but derivative of u, not with respect to x, with respect to time, is going to equal 3, or with respect to t, whatever they mean for t to be. You can cross multiply, make it du equals 3 dt, and solve for dt, get dt by itself. So du over 3 equals dt. And this and that will come in handy. Go back up to the original. So here goes in the original. It's secant squared of u plus secant u tangent u. And then instead of dt, we said down here we could write du over 3, like that. All this we can use our trig antiderivative rules for. So we know antiderivative of secant squared is tangent, so equals tangent of u. And antiderivative of this is secant, so plus secant of u, all times the fraction 1/3, and I should have put that out front, I'll just put it here for now, plus c. So in your final answer, maybe I'll leave the parentheses, just slide the 1/3 out front, and then I will also sub back in the 3t's instead of the u's. So just transferring this up where I have a tiny bit more space. Do I have a tiny bit more space? We'll have it equal the 1/3 coming first, tangent of 3t, because I had 3's in my problem, plus secant of 3t, and don't forget the plus capital C. Should look good. All right, speaking of another problem in terms of t, let's look at the very last WebAssign question. So this one is the word problem, and I want to talk a little bit about how it's presented and remind you of some notation. It says a population of bacteria is changing at a rate of. Changing at a rate of is wording that indicates that I'm given a derivative, and we have to integrate to get backwards to an original function. This dp dt, don't let it throw you off. It's just the change, the rate of change in population with respect to time. What we would have called it in class is p prime of t. These are both pieces of notation that mean the same thing. We have a derivative here, and we have to integrate, like I said, to get to a population function. They give us initial population, where I have this red number here. They give us a derivative function that we have to integrate, and then there's that follow-up question at the end. Once you have a function set, what happens when you plug into? So let's try this. I guess step one is going to be to integrate. So we want to find P of t, and we want to integrate that rate of change that's given, 2,900, or whatever your number would be, plus or over 1 plus 0.25t, all taken with respect to t. Another problem where I just have to think in terms of t instead of what we're used to in terms of x. So let's let u equal something. Here's a case where, what are my choices? We could make u the top, but that's a little weird because why would you make u a constant? We've never done that before. We could make u the bottom, which I think is a great idea. Or we can make u, I guess, just t, but that won't simplify anything. That'll just give you the same function back. So let's let u equal the entire denominator. If the denominator had parentheses around it and a power or a root or something, we wouldn't include that power in our u substitution, but we just don't have that here. We just have a chance to make the whole denominator u. And here's an expression for the derivative of u with respect to time, which is just 0.25. And we solve this for dt. dt equals, we'll say dt equals du over 0.25. Okay, so I think we're set to sub back in. Into the original, we've got, I have a 2,900. We're going to divide by just u, and then in for dt, we can put du over 0.25. The constants are not a big deal. I'm going to take my calculator. I'm going to plug in 2,900 divided by 0.25 to get 11,600. So it's the integral of 11600 in my problem times 1 over u du. Just another way to write what we had in red in the step before this. And now we have a special rule for the integral of 1 over u. Things I hope that you remember. I hope you remember to just put a constant and leave it out front. I also hope you remember that this is a derivative of ln of u, but be careful, not just u, absolute value of u, if that's ever going to be a final answer, and then plus c. So our p of t, which is already written, in the first blank, you can put your function in terms of t. 11600, natural log of what we called u, so 1 plus 0.25t, and then plus capital C at the end. That's answer number 1. Answer number 2 just has to do with the plug-in. In my problem, there's something I forgot. I forgot to get C. So that isn't answer number 1 yet. I guess what I should do next is use this initial condition. When t equals 0 in my problem, p of t equals 1100. So 1100 equals 11600 ln of 1 plus 0.25 times 0, so 1 plus 0 plus c. This is the natural log of 1, which is actually just going to be 0. This whole thing turns out to be 0, and in my problem, c gets to be 1100. So I would say when you type in your answer for this first part, instead of putting plus c in the end, can you put plus that value? All right, lastly, the follow-up question, find p of 2. Well, I'll write out my function first. My function that was the answer for the first part, one more time, is this, ln of 1 plus 0.25t plus 1100. And now I've got to just plug in 2. That's the last step. I want to find p of 2. So 11600 ln of 1 plus 0.25 times 2 plus 1100. And that can go straight into the calculator. And does it say I can round? It says round to the nearest whole number. So I quick type that in, 11,600 natural log of parentheses 1 plus a quarter of 2. And I'm dying to know what this is going to be, plus 1100. So I got 5803. And this is with my numbers. Yours will be different. 5803.395. So rounding to the nearest whole number, that would just truncate. I could just put 5803 for P of 2. All right, enjoy the rest of your day. Keep up all the good work. Keep the questions coming. Miss you all.